Well, hello everyone. Today we're going to be looking at a little something called bow ties and hat angles. Not too difficult of a lesson, shouldn't be too bad, so I hope you enjoy this fabulous video as we go through it. So here's the first thing. The theorem that we have right here says, when two chords intersect the interior of a circle, the measure of the angle formed is half of the sum of the two intercepted arcs. We refer to these as bow ties. Why me? Why would you say it looks like a bow tie? Well, let's take a look here. If you see the outline that we have right there, if you play the let's pretend use our imagination game, you kind of see that they look like a bow tie. Here, we can even dress it up. We can put little pretty polka dots on it. Yeah, now that's a pretty bow tie. But when you do get these bow tie looking shapes, here is the formula that we're going to be using. It's that your angle is going to equal 0.5 of the Eaton arc 1, which could be, let's say, this guy right here. I'll do this guy in red. Could be like this here, and then you have your other Eaton arc. We'll make it in the beautiful color of green, plus this. The key word here for this particular guy is the plus sign. And you'll see that as we kind of get to our hat angles, and you'll see the difference between the two, but just know that you are going to be adding the two arcs that we're giving you. So let's take a look. Let's start looking at a few examples here. So the first example we have here is find the missing arc or angle. So in this case, we're looking for that dude X right there. First things first, you got to see, is this a bow tie or is this a hat? Well, we haven't quite done hats yet, and if you take a look again, it's got that little bow tie looking shape here, see? Ooh, pretty. Look at that guy, looking like a bow tie there. So, what are we doing with this? Well, I'm glad you asked. Here's what we have. First, we want to get X. So, to get X, we'll start off with just putting X. Not a bad start. That equals, now if you look back on our formula right above, you see 0.5. So we're going to have X equals 0.5, and then we want the two arcs. Well, what's the arc? One of the arcs here, we have right there, 85. So that's going to be the first one that we're going to have here. 0.5 times 85 plus, again, plus. I can't emphasize the plus enough when we're talking about bow ties here. We're going to add it with the second arc that we have here, or this 107 that I have so wonderfully shadowed. And now we're ready to rock and roll. First things first, we got to add what's inside of those parentheses. So you want to take that 85, 107, and obviously we're going to add them together. So you're going to have X equals then 0.5 of 192. And then what is half of 92, or 0.5 times 92? You're going to get X equaling 96. That is legitimately it. That's all you have to do for number 2. With that being said then, number 2, this guy right there, you're doing it. That's you. So you make this like what we have here. Very beautiful. Now if we take a look at number 3 though, we kind of see, and I'm going to kind of get rid of that so we make it a little cleaner. You look at number 3, it's different than like what we have for number 1 and 2. So let's take a look at how we get this. Well, again, we're looking here at a marvelous bow tie. We have it here. It goes around here and down and there. Now, some of you might go, well, why wasn't it the ones that are associated with this 96 and maybe this 42? You got to take a look at where your X is. Your X has to be included with your bow tie. You don't want to exclude X. Did you like how I did that? Yeah, I know you did. But you have to keep X within the bow tie that you're looking at. So what that means, though, is that I need to figure out essentially what is this arc and then what is this arc. That then leads us to the two numbers that we're given, 96 and that 42. Well, again, think of it as those are leftovers from the arcs. So what we can do here is, well, we know a circle adds up to 360 degrees. So if we then subtract 96 and we subtract 42 from 360, that we're going to get a leftover of 222 degrees. That means that when I have, and I'll choose a different color here, ooh, purple highlighter, that's pretty. That means that those leftovers, that this and this, when we add those together, are going to equal what we have here for that 222. Now, it doesn't matter which one is what, as far as like this could be 100 and this could be 122. That doesn't really matter. We just need to make sure that we have this number, because then we can plug it back into our formula to make it work. So here's what I'm trying to say here. You're going to have x equals, you got that 0.5, and you're going to multiply it by 222, because that's what both arcs are combined. So like here, we combined, we had this arc for 85, and we added it for 107, which got us that 192. Well, now that we know that it's 222 here, we can say that is the combination of what we would have for this arc here and that arc right there. Anyway, let's take a look here. We got to then do 0.5 times 222. That's going to give us x equaling 111 degrees. Questions will be answered tomorrow if you have them, but we want you then to give number 4 a shot. That is going to be just like what you saw with number 3. Okay, number 5 then. Number 5 is kind of like the last type of problem that we're going to be looking at here for these bow tie angles. So again, let's kind of take a look at where we're exactly looking at here, and that's this here, this bow tie right there. Now, this time we know what the arc is. We know that this guy right here, we know that guy is 106. We're trying to figure out what x is. So we want to kind of plug it back into our formula and to figure out, well, what is that x then going to be? So let's take a look. Well, originally, like for we see for all the other problems, we're going to start off with 106, because that's what this and what this would add up to. So we have 106, that's going to equal then 0.5, and we're going to multiply it by what we know, or the two arcs. Well, we got 136, and then, well, we have x for the other one, hence right there. Now, let's work the math. We're going to distribute this 0.5 here to both parts. We're then going to have 106 equals 68 plus 0.5x. And then we're just solving this like normal algebra. So meaning we're going to subtract 68. We're going to subtract 68. And now I have myself 38 equals 0.5x. And when we divide by 0.5, we're going to get x equaling 76. Bam. All right. So with that said, give number 6 a shot. That's going to be just like number 5. All right. Flip your sheets to the back side. And let's take a look at what we have. Well, let's do some review first, all about the vertex. So if we're given this guy, the first one being the center, if we're giving you straight up from the center, the angle that is going to be there is going to be the exact as the arc that you have. If it's on the circle, so like if I'm asking for, let's say, x here, it's going to be that the inscribed angle is going to equal 0.5, or half of what the arc is. And then if we're inside the circle, just like the bow tie that we're looking at, the bow tie angle equals then 0.5 of arc 1 plus arc 2. So that should be a good refresh in the memory from this past week. But let's now move on onto the last part, the hat. We're going to look at this theorem, which states that when two segments intersect outside of a circle, the measure of the angle formed is half the distance of the two intercepted arcs. These are going to be referred to as your hat angles. Why? Well, look at this dude. Let's say he's smiling. It looks he's a happy dude. Maybe it's his birthday. Look at this. It's like a birthday hat. Isn't that really cool? And maybe we can put a little bit of flair in it. Maybe, yeah, that's some cool looking hat. The point is, if you take a look, it looks like a party hat. Hence why we are calling it hats. It's not just, a random coincidence. We do it for a reason. Now, let's take a look here, because we got to look at the formula. It's a little bit different than the last one. And by a little bit different, it's really much of the same, except this is saying subtract. That's going to be the big key. But let's take a look at the entire formula anyway. It says the tip of the hat equals 0.5 of the big Eaton arc, or arc 1, minus the little Eaton arc, or arc 2. So with that being said, we want to kind of, again, make sure that you're subtracting when you're getting these hats. So let's take a look at a few examples here. So here's what I want. I want the tip of this hat. I want the tip of the party hat. I think party hats are cool. So with that being said, we're going to try to get it. So we don't know what that is. That's our x. That's then going to equal, again, 0.5, and you have your 2 arcs. Your 2 arcs here are going to be from this arc, or this 36, and this arc here, and that's going to be your 188. So essentially what we have here, again, x equals 0.5, your arc 1 being 118. You are then going to subtract it from the second arc, or 36. Again, we're going to be subtracting with these numbers, so make sure that you have the bigger number in front of the smaller number where you don't really want to work with negatives here, okay? Great. I'm glad that you have that understanding. So let's start. Parentheses tells us that that's what we have to do first. We're going to take that 100, we're going to take that 118, we're going to subtract it from 36. So then we're going to end up with x equals 0.5 of 82. And then half of 82, well, x equals then 41. Bam. That simple, guys. That simple. Number 2 looks exactly like number 1. Or just like it. So I want you to guys give that a whirl on your own. So now let's take a look at number 3. A little bit different here. Why? Well, we're still looking for the tip top here, but we only have one arc to work with, this 120 here. Now we need to figure out what the other arc is. Well, if this from here to here and this arc, oh, and there we go, there's my color. If this is 120, we then need to figure out, well, what is the rest of this? But that's easy, right, guys? Because you should know that if you know that one part of the arc is 120, you can take your 360, or the total degree measure of the circle, and just subtract 120 from it. That'll give us then that leftover, or that other arc, which is then going to be 240. So it means this little green arc here, we're looking at 240 degrees, guys. And now we're ready to continue on playing just like number 1 and number 2. So we're still trying to find x, the tip top of that hat. So that's going to be x equals, we have then 0.5, and we're going to multiply it by 240 as our one arc. And again, we're subtracting it. Remember, hats mean subtraction. We're going to subtract it with 120. So do your parentheses first, getting x equals 0.5, 240 minus 120 being 120, and then half of 120, or 0.5 times 120, is going to be that magical number of 60. Isn't that cool? Of course it is. You love it, and I do too. All right. So number 4, just like number, no, we're going to do number 4 together. I'm going to have you guys actually do number 6. I'm just letting you know that right now. But let's take a look at number 4. That's a little bit more standard. So this shouldn't be too bad at all. We got here, we're still looking for the tip top here. So we have x equals, this is then going to be 0.5. We have already our first arc, like what you see right there. So we have that as 127, and then we're going to subtract it from the second arc that we have, or 59. Do your parentheses first. So you have x equals 0.5, 68, and then half of 68, meaning x equals 34. It's beautiful. It's absolutely beautiful. Now number 5. This time, if we look, we do have the tip top of the hat. So instead of actually being x, we're going to have 39 being what we're starting out with, which is then going to equal 0.5, and we have only one arc. Well, let's take this big arc first, the x we don't know, because that's going to be one of our missing arcs that we have, or the missing arc that we do have, and let's subtract it from what we actually know, or that's 66. Could you have the other way around? Yeah, but let's just kind of keep it like this. So we're going to first do what 0.5 of x. So you have 39 equals then 0.5 x, and then 0.5 times that negative 66, negative 33. Then let's just solve. You're going to add 33, and then you're going to end up with some 72 equals 0.5x. We then are going to then divide by 0.5, divide by 0.5, and get x equals 144. All right, guys, like I said, give number 6 a shot. Make sure this is done tomorrow, and you should be good to go. We'll see you guys tomorrow. Have a great rest of the day. Bye-bye.